KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we are going to discuss 12 and 13th problem. 12th problem first and then 13th problem. Okay, right. See here, the first problem is the gravitational attraction between electron and proton in a hydrogen atom is weaker than the Coulomb attraction by a factor of about 10 to the power of minus 40. Full stop. An alternative way of looking at this fact is to estimate the radius of the first Bohr orbit of a hydrogen atom if the electron and proton were bound by gravitational attraction. You will find the answer interesting. Okay, right. So it is what he is comparing two things, that is here itself we are getting both electrostatic force and that is what gravitational force. Okay, and you see here the gravitational attraction between electron and proton, the gravitational attraction between electron and proton in a hydrogen atom is weaker than the Coulomb attraction by a factor of about 10 to the power of minus 40. So this we had, right? When you are in first year, right, in the chapter of that is what gravitation, you got it. There are four forces in the universe, gravitational force and electromagnetic force and weak nuclear force and strong nuclear force, right? And if we compare the relative strength and if we compare the range up to which a force acts, right, there itself we got this information. So whatever he is saying here, that is what gravitational force or gravitational force of attraction or gravitational attraction between electron and proton in a hydrogen atom is weaker than the Coulomb attraction, by a factor of about 10 to the power of minus 40, 10 to the power of minus 40. Okay, right. An alternative way of looking at this fact is to estimate the radius of the first Bohr orbit of a hydrogen atom if the electron and proton were bound by gravitational attraction, right? You will find the answer interesting, right? So that is what the same thing we are checking from two different, okay? And see here that is what is the formula for radius of the first orbit in Bohr's model? What is the formula for the radius of the first orbit in Bohr's model is given by, the radius of the first orbit in Bohr's model is given by, what is that? R naught is equal to h square by 4 pi square m naught k e square. R naught is equal to h square by 4 pi square m naught k e square. This is the formula for radius of the first orbit in Bohr's model. Radius of the first orbit in Bohr's model is given by r naught is equal to h square by 4 pi square m naught k e square. Okay, right. If instead of electrostatic attraction between electron and proton, we consider the atom bound by gravitational force, that is what G into ME into MP divided by R square. This is what Newton's law of gravitation, right? And according to the Newton's law of gravitation, right, any two bodies are any two bodies in this universe attracts with certain amount of force, and that force acts along the line joining the two bodies, because very well force is a vector quantity. It has both magnitude and specific direction. We can also resolve the force into its components, and you can also that force vector also satisfies the laws of vector addition, right? So that is the reason force is a vector quantity. Gravitational force or electrostatic force, whatever it may be, basically these are the forces, no? So these are the vector quantities. Okay, right. Come back to this topic. This formula comes from Newton's law of universal gravitation. According to the Newton's law of universal gravitation, right, any two bodies in this universe attracts each other with certain amount of force, that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So that is what F is directly proportional to m1 m2 and F is inversely proportional to r square. That is what we got from the chapter of gravitation in first year. Okay, right. And here the same thing, the same Newton's law of gravitation or the gravitational force of attraction here between electron and proton. Very well from the atomic structure, right? There is a nucleus inside the atom, right? That nucleus consists nucleons. Nucleons means here basically neutrons and protons. Okay, and outside the nucleus there are orbits. In those orbits the electrons are revolving. Okay, so when the electrons are revolving in those respective orbits, basically electron has negative charge, right? So the proton has positive charge. So neutron has no charge, it has mass, right? So the nucleus possesses generally positive charge. There is attraction between electron and proton, right? That is what with respect to the mass is one point. That is what gravitational force of attraction or gravitational attraction. Regarding the charge also some other point. So regarding the masses, gravitational force of attraction or gravitational attraction, and regarding the charge, it is electrostatic force or electrostatic attraction. Okay, right. If instead of electrostatic attraction, right, gravitational force of attraction means the formula is G into m1 m2 by r square, right? But electrostatic force of attraction or electrostatic force means between two charges we have to go for Coulomb's law. That is what F is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. That will be different, right? So that is between two charges. Regarding the charge, okay, even though there is mass, because right, and regarding the charge, that is the electrostatic force. Okay, right. And if you see from the point of gravitation, that is what from Newton's law of gravitation, between electron and proton, you can write like this. We consider the atom bound by gravitational force. This is that is what relation G into ME MP by R square. G into ME MP by R square. Then the term K E square, see here. Then the term k e square should be replaced by GMPME. GMPME, right? So it is what radius of the first orbit in Bohr's model is given by R naught is equal to h square by 4 pi square m naught k e square. But if instead of electrostatic attraction between electron and proton, we consider the atom bound by gravitational force Gme into mp by r square. Okay, then the term k e square should be replaced by Gmp into me. The term k e square should be replaced by G into mp into me, right? Okay, and you see some other thing, that is what the radius of the first orbit in a gravitationally bound hydrogen atom will be like this. That is what just in place of k e square, we are writing, that is what G into mp into me. See here, right? Okay, that is R naught is equal to h square by 4 pi square me, sorry, 4 pi square here, that is what that is me, that is me. Okay, 4 pi square here, this term k e square, right? K e square is replacing with G into mp into me here, right? So here G into mp into me, already one me is here, so that we will get this one. This is the value of radius of the first Bohr orbit in a gravitationally bound hydrogen atom. This is the radius of the first Bohr orbit in a gravitationally bound hydrogen atom. Okay, right? And now, we are going to find this value. Very well, that is h is the Planck's constant. The value of Planck's constant is 6.6 into 10 to the power of minus 34, joule second, and 4 is a constant, and pi is 3.14 whole square, that is what the square is there, and G value 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So anyhow, that is what Newton meter square per kg square is the SI unit. That's why no problem, directly you can substitute. As usual, regarding the h value, I told you h value in terms of joule second, that is also SI unit, right? And that you can direct substitute, and 4 is a constant and pi has no unit, right? Then mass of proton, and afterwards mass of proton and mass of electron. Okay, right? So by writing all these things, that is what according to the question, according to the relation, right? So according to the question we had okay, this is the basic formula, that is what radius of the first orbit in Bohr's model, right? And then when the atom is bound gravitationally, then I can replace the term k e square with G into mp into me, and if you replace, then the modified form of radius of the first Bohr orbit in a gravitationally bound hydrogen atom will be, this is what R naught is equal to h square by 4 pi square G into mp into me square, right? Now we are substituting the values in this relation, that is what every value, that is what is the Planck's constant, 6.6 into 10 to the power of minus 34, and divided by, in the denominator, 4, pi is 3.14, this is the whole square, and then mp, that is 6.67 into 10 to the power of minus 11 into me, that is 1.6725 into 10 to the power of minus 27 into 9.1 into 10 to the power of minus 31 whole square, right? Okay, that is equal. So you do this calculation mathematically, here multiplications and here square term is there, and then division, right? and power terms are there, right? So by doing all this process, a mathematical process, purely mathematical process, and simply it's what calculation, okay? That is what calculation, right? And if you do that calculation, you know, you will get it as 1.194 into 10 to the power of 29 meter. That is approximately, you know, rounding off, right? What is rounding off here? You know, the last digit is less than 5, the preceding digit will not change. You know, the last digit is greater than 5, the preceding digit raised by 1. So that is what rounding off method we learn in the chapter of units and dimensions. Okay, right. So if you apply that rounding off method, you know, here you will get it as 1.2 into 10 to the power of 29 meters. 1.2 into 10 to the power of 29 meters, right? So this is what this radius is much greater than the estimated size of the whole universe. You know, this radius is much greater than, this radius is much greater than the estimated size of the whole universe. Estimated size of the whole universe. That's what he is saying. This radius is much greater than the estimated size of the whole. You see this ma? Is 10 to the power of 29. 10 to the power of 29. Okay. So that's what according to this problem is like what is imagination oriented, and that is what somewhat a logical conclusion, right? So if you replace, that is what electrostatic, I mean see, the gravitational attraction between electron and proton in a hydrogen atom is weaker than the Coulomb attraction by a factor about 10 to the power of minus 40. This you know. So that's why an alternative way of looking at this fact is to estimate the radius of the first Bohr orbit of a hydrogen atom if the electron and proton were bound by gravitational attraction. Actually were bound by charge, no? Were bound by charge, okay? Were bound by charge, right? And so if you do like that, what will happen means this is the radius of the first Bohr orbit in a gravitationally bound hydrogen atom, that is 1.2 into 10 to the power of 9 meters. Okay, right. Next question. Obtain an expression. See here. Obtain an expression for the frequency of radiation emitted when a hydrogen atom de-excites. Obtain an expression for the frequency of radiation emitted when a hydrogen atom de-excites, when a hydrogen atom de-excites from level n to level n minus 1, from level n to level n minus 1. Okay, I will repeat once again ma. Understand the question. Obtain an expression for the frequency of radiation emitted when a hydrogen atom de-excites from a level n to level n minus 1, full stop. For large n, we have to show that this frequency equals the classical frequency of revolution of the electron in the orbit. This frequency equals the classical frequency of revolution of the electron in the orbit, right? So he is asking to show the frequency what we are getting here, that is equal to the classical frequency of revolution in the electron in that orbit. Okay, right. See here. From Bohr's theory, you know, the frequency nu of the radiation emitted from Bohr's theory, the frequency nu of the radiation emitted when an electron de-excites from level n2 to level n1 is given by. So this is the formula for frequency when the electron de-excites from level n2 to level n1. It is the formula generally, right? That is what 2 pi square m k square z square e power 4 divided by h cubed into 1 by n1 square minus 1 by n2 square. This is a general formula. But according to this question, you know, so it de-exits from level n to level n minus 1 now. So n1 is equal to n minus 1, and you know n2 is equal to n, and write down these values in this equation. That is what you see here. Therefore nu is equal, is the frequency not the velocity, is the frequency. Okay, right. Nu is equal to 2 pi square m k square z square e power 4. Same formula, whatever is here, that only I am writing. But in place of n1 I am writing n minus 1. In place of n2 I am writing n. In place of n2 I am writing n. Okay, right. And you know the same thing will come here. It is what mathematically you can take that LCM and you do that. Okay, n minus 1 square into n square, and Mela, right here the top will become like 2n minus 1. Okay, right. For large n, 2n minus 1 is equal to 2n. For example, large n means it is like 1 lakh, okay, whatever it may be the value, you just imagine yourself, right? So more value, high value, you know, when compared to the 2n, if this is like 1000 or 10,000 means, right, the 1 is negligible, no? For example, I am saying not 1 lakh and not 10,000. So when this value is larger, and you can take 2n minus 1 is equal to n, and n minus 1 is approximately equal to n. And for hydrogen, z is equal to 1, that is therimo, okay, z is equal to 1, okay. Now you come back to this expression, that is what nu is equal to 2 pi square m k square e to the power of 4 divided by h cubed, because z is equal to 1, okay, into this value 2n, and it is n square into n square, right. From this we are getting this one, that is what here 4 pi square m k square e to the power of 4, right. And you know here n power 4, here n cubed will come, h cubed is as it is like equation number 1. It's okay, it's the frequency, right. Now in Bohr's model, what is the velocity of electron in nth orbit? This is the velocity of the electron in nth orbit. And what is the radius of the nth orbit? This is the radius of the nth orbit, n square h square by 4 pi square m k e square, right. So then what about the orbital frequency of the electron in nth orbit? That is what nu is equal to, that is what v by 2 pi r, v by 2 pi r, okay. So when it is v by 2 pi r, that is equal to, you know, 1 by 2 pi r into, we are writing v value, that is what here nh by 2 pi m r, here we are writing, okay. And we also have r value, that is what radius of the nth orbit, right. So that we are writing here, in place of r we are writing, okay. That is what actually here r square is there, okay, that r value therimo. So that r value we are substituting here, then finally we are getting this one, that is the frequency 4 pi square m k square e power 4 divided by n cubed h cubed. You see these two are same or not? Yes, same. So what can we conclude? So here I have written clearly, which is same as obtained in equation 1, which is same as obtained in equation 1, right. Okay, see here. Hence for large value of n, see here we took assumption, hence large value of n, the classical frequency of revolution, hence for large value of n, the classical frequency of revolution of electron in the nth orbit is same as that obtained from Bohr's theory, is same as that we obtained from Bohr's theory. This is what classical, and this is what Bohr's theory, both are same, no, but there is some assumption, that's why he mentioned here, you know, for large value of n, the classical frequency of revolution of electron in the nth orbit, is same as that obtained from Bohr's theory, okay, right. So in this class we focused on two problems, right. And in the first problem, you know, that is what like comparison. So he is asking the possibilities regarding the radius of the first Bohr orbit when the atom is bound, right. So when the hydrogen atom is bound gravitationally, right. So there we are getting radius of the first Bohr orbit like 1.2 into 10 to the power of 29 meters, right? So this radius is much greater than the estimated size of the whole universe. Okay, right. And after that, in the second problem, we calculated the frequency, the orbital frequency of electron in the nth orbit from two different aspects. One is Bohr's theory, and another one is classical frequency of revolution. That is what, by having a v value, that is velocity of electron in the nth orbit, and by knowing the radius of the nth orbit, right? And generally the formula for frequency, that is what, v by 2 pi r, and from there also we calculated. And the conclusion is here, for large value of n, the classical frequency of revolution of electron in the nth orbit is same as that obtained from Bohr's theory. Okay, right, that's all. So this is all about two problems. Okay, thank you. We will continue in the next class.